Okay, chapter 17, number 15. We're talking T procedures now and T tests and T intervals. And now remember, T intervals and T tests come when sigma is unknown, and we use S, the sample standard deviation, to estimate sigma, because sigma is the population standard deviation. Okay, 15. We prefer T procedures to the Z procedures for inference because um, Z can be used for large samples. Z requires you to know the population standard deviation. Z requires that you can regard your data as SRS. So I just answered that question. You have to know sigma for Z. 16. You are testing mu is 10 against mu is less than 10 based on an SRS of 20. The data gives X bar is 8 and S is 4. What's the T statistic? Okay, well, let's pull this up and see. Let me get my calculator up here. Move that over here. Okay, so stat test, we're going to do a T test. And we've got H0 is 10. HA is, or X bar, I'm sorry, is 8. Standard deviation is 4. Sample size N is 20. We're assuming all our conditions are satisfied. And what are we testing? We're testing less than 10. So that's going to be this guy right there. Okay, less than mu 0. That's my H0, which is up there, is 10. Calculate. So T is negative 2.23 or 2.236, which is 2.24, which is that guy right there. Okay. 17. If you're testing mu equals 10 against mu less than 10, 20 observation from a normal population, the T statistics is negative 2.25. Degrees of freedom. Remember, degrees of freedom is always one less than the sample size. So degrees of freedom would be 20 minus 1, which is 19 degrees of freedom. The p-value for the previous exercise is 0.019. So 0.019 between 0.01 and 0.02. Right? Okay. And 19, you have an SRS of 15 from a normally distributed population. What critical value would you use to obtain a 98% confidence interval for the mean mu of the population? So I'm going to look up on the back T table in the back, and I'm going to look up 98% confidence. And I'm going to go down to degrees of freedom. Since the sample size is 15, I'm going to go to degrees of freedom 14. And I'm looking at 2.624. T equals 2.624. Oops. Got right there, right. Okay. All right. There you go on that one.